Hi everyone, welcome to another video, and today we'll be discussing a new data structure called linked list, and this is an important one. So we will be discussing what is a linked list on the whiteboard, and then we're going to implement the same using JavaScript. So what is a linked list? A linked list is an object oriented data structure, we can say, where every value is, for example, we have a value like maybe 5 and 10 or so on, where every value will be pointing to the next value. So let's arrange that in a object structure. First thing, we have like a value maybe 1, where value is 1 and next equals to null. So this will be our first node, and when we kind of insert a new value, our new value will become, maybe we inserted 5, then 5 will be the new value, and the next of this object will be pointing to our previous value, and so on. So our structure will be creating a chain structure where every node will be pointing to another node, and that's how the linked list data structure looks like. So how are we going to implement it using data structure? So first we're going to create a node. That node will have, let's create constructor that will take a value, and we'll have a next pointer. Let's give default value as null, and whenever we call that node, it will give us a new node, and that node will have a value and a next pointer. Okay, then we will create our linked list class where our head will be our initial value, that is null. Then we're going to create our methods. The first method we're going to create is obviously insert, right? We're gonna, let's create our default methods like get head, that will return our head, and then we're gonna create get tail, that will return our last node of the linked list. Then we're gonna create definitely insert, where we're gonna keep that we're gonna use to insert values to our list. That will take a value and insert it into the list. Then we're going to create another method that will insert last. This will take a value and insert it at the end of the list. Again, not all those methods are required to implement a linked list, but I'm creating it so that by creating it, we're going to go deeper to implement linked list, and not only implementing linked list, but also to know how to traverse through the nodes and manipulate the nodes and all. So after implementing this linked list class, we will get familiar with everything. And then insert last. Then we're gonna create another method that will return the size of the list, that is the length. And then we're gonna implement another method called insert at. So this will take a index and a value, and it will iterate through the list, and wherever our index matches, maybe I will give like 1 index and 100. So whenever the index is 1, just like an array, or whenever we find the 1th element, it will insert the value there or create a new node. So insert at, same way we're gonna create remove at. Or it will take a ID and remove that particular value from that particular index. So we create a remove at. Then let's create remove head That will remove the head, and we're going to create another one, remove tail as well. That will delete the last node of the list. What else? Another one we can insert is once we insert, let's create another one, get node at. So we're going to give a value and it will traverse and return that node in particular index, in that particular index. Also we can create another method called for each, right? That will kind of take a function and run that callback on every node so that we can manipulate the value as well. This is not required, but yeah, we can do that so that we can manipulate every node's value. For example, we want to multiply every node's value with 10, so we can use this method and can do it. So now let's implement one by one. So first thing we're going to implement is get head. It is the simple one. It will return just the head node. Return this dot head. Simple. When we're going to do the tail, it's going to traverse through the node until we're going to find the null, right? Whenever the next is null, then that is our last node, and it should return that node. So let node equals to this dot head, and it's gonna run a loop while node dot next, node equals to node dot next, and at the end, when our node dot next is null, at that time our node will be the last node, so we just have to return it, and that will give us our last node. Insert, definitely it will insert every node at the beginning. So we're gonna create like insert every time. It's gonna take like this dot head equal to a new node, and it will take the value as current value and our current this dot head as the next. Simple, and it will insert the value at the beginning. Insert at the last, the same thing. We have to iterate until we find the last node, and just when we find the last node, at that time we have to insert the value. So same way, let node equals to this dot head, and then we just have to while node dot next, node equals to node dot next. So at the end, when the next will become null, that will be our last node. At that time we just have to insert the value. At that time, just node dot next equals to new node val, and that should do the trick, and it will insert at the end one node, right? Now this is a interesting one. So here we have to count. For example, we insert a 4 or 5 or something like the number of that node, and we have to count. We have to track the count as we traverse through the node, and we increment the count for every next counter or every next while loop, right? And when the count matches our ID, then we are at the proper node where we have to manipulate the next pointers. So we have to keep track of previous and next, and whenever we get the counter equals to ID, we have to point the previous next to a new node and new nodes next to the previously next node. That's how we're going to do it. So get node at ID. So let's do it here. What you're going to do here is same. Let we have to keep a counter first, so let I equals to 0, right? If id equals to 0, then we just have to return the head, right? We don't have to do anything because our head will be at 0's index at anyway. Or if we do while loop, then also, you know, yeah, inside while loop also we can write it. Dot head, so we can write it here as well. While node, if I equals to id, so when it is 0 anyway, it will gonna return the node. Right, anyway it will return the head if we are sending 0, because by default the id will become 0 and it will return the node and break. So for 0 it will return the head anyway. After that we have to do like node equals to node dot next, and we have to do I++. Simple. So our get node is done. Size is also simple. Size, we just have to count it, and whenever at the end of the node we reach to the end of the node, we just have to return the count. So let node equals to 0 and node equals to this dot head. It's the same logic. While node equals to node dot next I++ return I. So for the first node it will be like 0, then second node it will be 1, until the last node find null. We just have to return the I and it will return the count. First thing first, our count should return the length, you know. So if you start from 0, it will become like less than 1 all the time. So I think we should increase it. We should start from 1. It's just like an array. If you start from 0 index, the total length will become length minus 1. So to return the total length, we have to start it from 1. Then it will return the correct size. Okay, insert at is like we have to give a like again we have to keep counting. Here we can start from 0th index because we're gonna give an index. So head will be our 0th index and so on. When the id matches our count, at that time we have to manipulate our nodes. Here we have to keep track of previous as well, so that we can point the next to another next, you know. So yeah, let I equals to 0 as usual. We're going to start our counter from the 0, and we have to keep track of previous. First the previous will be null, and let node equals to as usual this dot head. Then we're going to run a while loop as usual, and we're going to node if I equals to id, then we get the position where we have to insert. So here our insert at. Okay, first we have to see a 0th point position, right? If id equals to 0, then it is just like this dot insert, well, because we have to insert at the first, right? Else we had to our previous dot next needs to be new node, and we're gonna insert our value, and our node will go to the next. And at the end of the while loop, we have to like previous equals to node equals to node dot next, and we have to increase our pointer I++. Yes, the similar logic will go into the remove at. Same logic, we just have to, here we added one node, here we have to remove one node. So let's write the same thing again. Let I equals to 0 as usual. We're going to start our counter, and let node equals to this dot head, and we have to keep track of our previous. First time it will be null. Then we're going to start with while loop, while node, and same logic exactly like inserted. We have to check if I equals to id, but if id equals to 0, then this dot head equals to this dot head dot next, right? We just have to point head to the next pointer, so it will get rid of the head. Else we have to do is previous dot next equals to node dot next, so it will get rid of the value of the node, and everything else will remain the same. We have to mark previously equals to node, then node equals to node dot next, and I++. Same logic as inserted, just we are getting rid of that value. Here we are adding a new node. Logic are same. Remove head is the simple, right? Like this dot head equals to this dot head dot next. Do we already have remove tail? No. Remove tail is a similar. By the time we get our next pointer, we have to keep track of the previous and just get rid of the node. So yeah, remove tail will be let prev equals to null, then let node equals to this dot head, and while we're gonna start the loop node dot next. We have to be at the last node, so we are doing node dot next so that our node will become the last node. So here node equals to node dot next, and our prev become node. So at the end, when our node dot next become like null, we will be at the last node. At that time we just have to make like previous dot next equals to null, and it will get rid of it. Now this is interesting, so that we have to just run a while loop. So let node equals to this dot head, right, while node, we just have to do node equals to node dot next, but here node dot val equals to our function call node dot val. So whatever callback we are sending to the method, it will be executed on the value, and that will return that will execute on every node. So that's all we need. Now let's see the test cases. Remove it. So first I am inserting 3 numbers, 1 2 3. So this will create a structure like this, right? 3 will become tail, 1 will become, sorry, 1 will become, this is wrong, 1 will become, 3 will become head, pointing to 2, and 1 will become tail. So here when we get tail, tail should return us 1, and head value should return us 3. Okay, and then I will insert at 4, so 4 will be inserted at the head. And if I do insert at last, if we have the insert last, say we change the name, so insert last, we do 5, then our head will become 4 and tail will become 5. Then we have insert at, then we gave an index and we send 100. So first index, that's after 4, it will be inserted. So when we again do get node at, and we give an index, it will return value as 100, because 100 will be now inserted at the index 1. And then we have a size to be written at 6 in this particular case, 1 2 3 4 5 6, because we have 6 values in our linked list. It will return us 6. Then we have created a for each, right, and we are sending a method that multiplies every value with 10. So whatever there was before will be multiplied by 10. So 4 will become 40, 100 will become 1000, 3 will become 30, and 2 become 20, 1 10, and 5 50. And after that, if I do a get tail, the value will become and do a value, it will become 50 now instead of 5. Now remove value at, so remove at, if I give an index 1, it should return the 1000 value, right? The 1000 will not be there. And now after removing, if I execute the size, right, remove at 1, the size should become 5 now. And then get node at 1 will become 30, because we removed 1000 was inserted at 1 index. Now the 1 index will contain 30, because we removed the 1000. Now again we do like remove tail. The remove tail will remove the 50 node. So the last node, if we do again get tail, the last node will become 10 now, is 10. Same way, if you remove head, the head will become the total linked list itself will become null because the head will be assigned to null. Do we have a remove head? Get head, get tail, insert, insert last, get node size, insert, remove at, remove head. No, this should be null. So completely we're removing the null. So now let's run our test cases. Something has failed. Oh, syntax error. So get tail. What else has failed? To be 1. Received 3. This dot head. Oops, see, this is the mistake. The insert value, we have to insert the value and we have to insert the not the next. The head itself should become the next. A lot of errors. The size returning are 7, so 1 we have to adjust that. Where is the size? So okay, we going to the node dot next, right? So by the time the next becoming null, already you will be counting. If you start from 0, you already have it, already have the value, so we don't have to start from 0, because here we're gonna count. If we do it 1, we have to make it node dot next. Perfect. Everything has passed. So this is a little bit complicated. We don't have to put all those methods to the linked list to implement linked list, but I just want to implement this all so that by the time we ending this, we will be get acquainted of all the methods, how we're gonna traverse through a linked list and we're gonna manipulate the nodes in the linked list, right? So that's all about linked list. Hope you enjoyed the deep dive. Thank you.